Hello, everyone, and welcome back to one of our overflow meetings where we try to walk the backlog to actually get it under control, because as you can see, it grows quicker than we can review, which is a good problem to have, I guess, because it means stuff is happening. So I already selected some items here, and we will start with this one here. Tanner, take it away.
Yeah, so Steven's probably also the right one to be on for this one since he owns it. But basically, Fred opened an issue asking for compare exchange to be expanded to cover the primitive types, as there's various usages needed for that in the compiler or various other locations. It just naturally simplifies things when you actually have a byte that you're working with.
Why did we call it location 1?
Because that's what we named in the other APIs.
Oh, is that what we did before?
Yeah, I
no
think
idea where that came from initially, but yeah, it's consistent with what we currently have.
Always good to have a location 1 and there's no location 2.
I think this is one of the many sets of parameter names where we'd go and fix them up if we were willing to take that break.
Oh God, what's happening here? Okay.
Quick question. I'm on mobile right now, so I can't really see the screen, but do we have an overload that takes enum?
No.
No.
Should we? Because I've had the scenario where I've had to interlock compare exchange enum values before.
I definitely have as well, but that one would require like extra specialization and care in the JIT to handle. I'm not sure if that's worth it over just telling users you can unsafe.as the enum to the underlying type.
I also think I seem to remember there being another issue for it, and I can't remember if we left it open or closed it, basically saying, you know, what Tanner just said.
Okay, yeah, because this gets us, most of the way there. And
this at least lets you unsafe as kind of regardless of what the base of the underlying type of your enum is. Because right now you're kind of out of luck if your enum is based on a byte.
Yeah.
But does this fully round out? I don't remember. We currently have int, uint, long, ulong, and there's another issue, and we have at least int pointer, and there's another issue for uint, and int, or nuint. Is that right?
Yeah, that's the proposal that's immediately following this one in the tab bar up there. So this one plus the next one, I believe, rounds out for the primitive types.
But this is only showing compare exchange. What about exchange?
I don't think Fred had a need for that, but add and don't have those. I'm not 100% positive that all platforms support add and for the small types, though. I know compare exchange they do.
Well, we can always implement add and ourselves if the platform doesn't support it.
Yeah, it looks like we basically don't provide the small APIs on any of them.
Logically, I group compare exchange and exchange in my mind together, and then everything else are sort of, the increment, decrement, and or are sort of often a separate grouping, at least in my mind. I'd be inclined to ensure that we have parity between compare exchange and exchange, even if we don't, assuming it's supportable, and supportable without doing our own custom loops, separate from what we decide to do for the other helpers.
Yeah, compare exchange and exchange are generally, when one's supported in hardware, both are.
Yeah.
And exchange and compare exchange are the only two that support like double and single, and arbitrary T constrained to class today. So it would make sense to just fully flush them out.
Yeah, I think parity between those two is a good thing. So if we add these here, which makes sense, we should add to exchange the corresponding byte, S byte, short, U short, and for the next issue, I guess, nuint to exchange as well. There was a question about which compiler this is referring to. I think from Fred's request, we're talking about Roslyn Fred works on Roslyn.
Which would be the C# and VB compilers.
That said, like we have plenty of places in .NET runtime where we've used an int to represent, a flag that just goes from 0 to 1, and we could choose to use a byte instead if it, if that was a field on something, and we could pack things a little bit more tightly.
Yep. So I guess the if we have these, we have the ability for full parity across the primitive types except for bool and char. But those could fall in the same bucket as enum, where we could say if you actually have a bool or char case, just use unsafe as.
That would be my preference, I think, unless it's really like super duper duper common.
Same with half, right?
Yeah, half is very special, and we don't have broad support for it anywhere yet.
Right.
But it's similar to single and double.
Right. So then, I suppose we're happy with this.
I don't remember what the parameter name for exchange is, but if it's location 1, then yeah.
It is location 1 XOL.
Awesome. We are so good at naming.
Yeah. I'm pretty sure that low-level APIs we historically haven't really reviewed because nobody cared enough. I think it's the.
I mean, these date back to .NET Framework 1.0, so who knows what the rationale was at the time.
Yeah, I bet you that value was called location 2 at some point.
I cared enough to make the intrinsic APIs named well.
Oh yeah. Well,
and we salute your efforts.
All right, so then the next one.
These all require JIT work, right, Tanner?
Yeah, if we want them accelerated, they will require JIT work.
Yeah.
Although since these ones are already accelerated for int in the other types, it should, knock on wood, be relatively simple for us to go and extend it to the other types.
Yeah.
Because it's the same instruction under the hood, just a different encoding.
Yeah, in some situations, I'm fine with us adding APIs with sort of the naive implementation and then later optimizing them. But in the case where someone might start switching from one of the existing ones to the new ones because it's quote better, I want to make sure when we add them the right way.
Yeah.
And why do we do JIT work? Why can't we just use the intrinsics in the implementation? And
these are the intrinsics.
Oh, we don't have actual.
Yeah, we don't have hardware intrinsics for these ones because this is considered baseline functionality in the CPU. There's no like ISA check or ready to run flags that need to be set or anything like that. This is just, CPUs provide the support because it's considered, functionally required for you to do multi-threading and stuff.
Yeah, fair enough.
And then same thing, except covering inuint.
And now that enuint pointer as of .NET 7 and C#11 are identical, it really doesn't matter whether this is approved as uint pointer or enuint, right?
Right. And ideally even once the language support goes in for inuint versus inuint pointer, we would go and switch to using the keywords in various places, just to simplify things.
Right.
So the basic premise is, we introduced 64-bit computers over 20 years ago, and a lot of other languages, from C++ to Rust, even Java and Go, have support for 128-bit integer types. These can often be partially accelerated by the underlying hardware, and most importantly, this is a type that the community cannot provide themselves. The reasoning being is that int128 is considered special by the ABI, the Application Binary Interface, which defines how two methods communicate between each other. And so an end user, while they could provide their own type named int128, they could provide all the operations, all the features. That type would actually not be usable in interop code. It would not be correctly packed. It would not be 16-byte packed, and a few other things, which means that this is one of the few types which is actually functionally required for the runtime to provide it.
So which ABI are you talking about? This is just the same that C and C++ use. Is that what you mean? Like mapping to the same spec? Okay.
Right. The underlying calling convention used by each platform. So normally there's a Windows ABI for 32-bit, 64-bit, and ARM64, and then there's a Unix ABI, which covers the same platforms, but which is used across both Linux and Mac OS. Sometimes Mac OS differs slightly, but they're generally in line, and that's the systemd specification. But previously we weren't able to expose this type in the BCL, even though users had been repeatedly asking for it over the years, and that's because we weren't able to define checked operators. And so if we had exposed it and the language had come along later and said, hey, we want to support this now too, it would have been a breaking change in the same way that int pointer to init was a breaking change. And so we weren't really willing to put users through that pain. But now that C# 11 is exposing user-defined checked operators, we can expose int128 and all the support except for literals and constant folding, largely speaking, and it will be basically on the same level as when we exposed half, which is that we can expose it in the BCL, and the language can support it at any time in the future when they deem appropriate, with only minimal breaking changes, largely around edge cases and operator resolution for casting and things like that. Since built-in language operators have a slightly different precedence for conversions. But the premise is basically this entire API surface is int128 mirrors what int64, int32, etc. does, and the same for uint128 with uint64, uint32, etc. With the only notable differences being that there is a constructor that takes the two halves of the value, and there being a set of implicit and explicit conversion operators, which match the normal safety rules, being allowed where it's implicit and disallowed otherwise. The only notable difference in that definition is that the conversions around the conversions to the floating point types I marked as explicit. That's inconsistent with how int64 works, but that operation is not safe. It is not lossless, and particularly with int128, you're going to see more and more values where the truncation becomes extreme. Since it's anything over 2 to the power of 53. So anything that uses more than 53 bits is going to potentially result in loss of data. And so I've marked them explicit, but that's not a strong preference. Otherwise, everything's identical to int64, just taking the int128 type.
When you say identical in terms of surface area, are you also accounting for methods like toString, for instance, where I can have similar behaviors with, say, hex formatting, things like that?
Yes.
Okay. Because I'm also wondering, did we ever end up enlightening APIs like system.convert with respect to half?
I don't believe so.
Okay. So we wouldn't do that here either, then, I guess.
I think that would be a decision we need to make. If we do it for int 128, we should likely do it for half and any other quote unquote primitive types.
Mhm.
Notably, convert is a case where with the new generic math operators, it's likely recommended that users just do t.create checked, create saturating or create truncating instead. Because that's simpler, it's going to already work, and then we don't have to touch convert moving forward.
Okay. Yeah, because I think what you have here as far as API surface, I think makes sense, especially since you're basing it on something that's already approved, right? What I'm more interested in is all of the like ecosystem impact from this. Do we have scenarios, for instance, where people want to convert between like GUID and int 128? Do we have scenarios where people need to pass int 128 across a p-invoke boundary? Stuff like that.
So int 128 across the p-invoke boundary does exist. That would implicitly work by the runtime correctly handling the ABI for the type. For things like GUID and stuff, I'm not convinced it's worth adding dedicated APIs for that. I think users explicitly using things like unsafe as to do the bitwise cast, or even exposing the API on bit converter, which is called GUID to int 128 bits, mirroring single to int 32 bits, for example, would make more sense. But I think those are also questions that we can answer and address over time as the need comes up.
Yeah, I agree with that. I only raised it because like I don't know if people were using GUID as today like a surrogate for the lack of int 128. It was brainstorming more than anything else.
Yeah.
What about relationship with the previous issues we were looking at? Can we rely on any or all the platforms we target having necessary primitives to do atomic, compare, exchange, and exchange?
For 64-bit, yes. At least on Windows, Windows requires a compare, exchange 16-byte support. More accurately speaking, if we were to expose a centralized API, it would be effectively compare, exchange 2 pointers or 2 native integers. And so on a 32-bit system, you can only do atomic 8-byte exchanges, and on 64-bit, you can do atomic 16-byte exchanges. And so it's really a inuint upper lower rather than in int 128.
According to MSDN, the alignment for a compare exchange 128 has to be 16 bytes. Does that mean that the alignment here will be 16-byte guaranteed for this type?
So that is an interesting thing where due to the way the GC is set up today, the GC will not guarantee 16-byte alignment. If you're doing interop here, you would want to use and the alignment is actually important for the underlying operations you're doing. You'd want to use native memory.alloc aligned, just like you would have to do with vector 128 and vector 256. The packing, however, would be correctly 16 bytes, and the stack alignment would be 16 bytes because we can respect it in both of those locations. It's only for the GC where the GC does not allow or guarantee above 8-byte alignment today, where we wouldn't be able to have that guarantee. There's a couple issues tracking a request around that for Maoni. And of course, you can manually allocate an array using the GC alloc uninitialized and pass an alignment.
Sure, and I guess what I was getting at primarily is if we do decide to expose, say, compare exchange of int 128, will people be able to just new up a regular array or use a regular field inside a type, or do they have to call native memory first in order to do that correctly?
They would have to call native memory or GC alloc with the alignment to guarantee the 16-byte alignment that was required by compare exchange 2-pointer.
I see.
The same would be true for 8-byte on 32-bit because not all platforms guarantee 8-byte alignment. There's some platforms where long, double, and others are actually 4-byte aligned. I believe ARM32 is one of them. And in that scenario, you can't actually even rely on 8-byte alignment for some operations.
Yeah, but I thought that those processors already handled correctly things like multi-threading when things weren't 8-byte aligned.
It depends on the processor. ARM32 is actually pretty famous for not allowing unaligned reads. And that's one of the reasons why it's so critical that we use unsafe.read and write unaligned when we know we have unaligned data.
Okay. Yeah, so I don't want to rat hole in like the interlock stuff here, but I'm wondering if maybe we would be in a situation then where we would say, okay, we would never add an overload of compare exchange that takes int 128, and if people want atomicity with these, then maybe that's better handled by atomic of t, which people have theorized.
Right. And the thing I was trying to get at is also we would never ever expose int 128 anyways. We would at best expose interlocked exchange over like a tuple pair of inuents. That way it is correct on 32-bit as well, because 32-bit can never do atomic interlocked exchange for int 128.
Well, honestly, for that scenario, I would be okay with telling people like you just can't do this. It throws an exception. But sure.
Yeah, that's potentially fair.
Okay.
So was that said when I was trying to reboot? But like this is the first time when the primitive would effectively have custom operators. Are we saying that the compiler will never have them built in?
Decimal has custom operators as well. And decimal is a language primitive, but not a runtime primitive.
And so we're saying 128 will never be a runtime primitive?
Even if it was a runtime primitive, it would end up being like, let's say that we went and said, we're going to extend the IL specification such that add works for int 128. There'd be open questions there on like, how do you encode that type? Because things like int32 are specially encoded. But outside of that, it would be no worse than what we're already in with int32, because generic math is exposing all these operators on the types anyways. They're just, they're explicitly implemented, but they're still there.
Yeah.
And so the language just knows whether int pointer is another. Int pointer is both a runtime primitive and a language primitive, but it exposes user-defined operators, and the language knows to ignore those and just emit the more efficient IL opcode instead. So if we ever added that support, the language could decide to say, hey, we know these are compatible and identical, so just emit the more efficient encoding.
Yeah, I'm just asking because I remember for the NPDR discussion that this was one of those sticky points where the language was not super happy with having both, right? I think if as long as we are saying like, yeah, there's nothing wrong with having them, that seems fine. I just want to avoid that we corner ourselves by saying, oh, we do them here now because the language doesn't have them yet or something like that.
Mm-hmm.
But basically what you're saying is we wouldn't do runtime work yet, but if we were to do it, then the compiler could start to emit it differently if they wanted to.
Right. And I'm not, I can always have the conversation with like David Wrighton and Jan on if extending the IL opcode is appropriate. But even then, C# wouldn't be able to use it without simultaneous support, and they're not planning on adding support for int 128 anytime soon. Like half, they want to wait until they see enough adoption in user libraries before they decide it's worth adding the additional language support.
That makes sense. And in the meantime, as long as you expose the public constructors, which you're missing on uint 128, by the way, then people can always create these things.
I just have a comment there that it's the exact same API, but and then call that the one place where it does differ, which is the conversion.
So along those lines, the constructors on int 128, should those be long instead of ulong just because it is a 2's complement representation, or are we good with ulong?
it's 2's complement representation, but it's actually very important that at least the lower one is unsigned. You don't want to suddenly try and conceptualize that the lower bit, the lower bits, even though they're, they don't have any sign impact, are suddenly carrying in sign information, or having to like conceptualize, oh, I've got to, I want to do 0x 80,000. But now I have to insert an unchecked cast to long because C# considers that a too large unsigned value.
Right. Yeah, I agree with lower. Upper, would we leave upper U long then just for consistency, and we just say like, hey, if you're calling this, it's up to you to understand that the bit pattern has to be 2's complement?
Yes.
Okay.
And in particular, I imagine that most users doing this will end up using hex. They likely won't be doing something like 0, negative 2.14 billion or anything like that. They'd likely just use the hex pattern to improve readability, and make sure that it can actually, you actually understand what the bits are. To that extent, it might actually be good to order upper first. That way you can read it from left to right with just a comma separating the two values. So it would be as if you wrote out a single 128-bit hex literal.
I mean, right now the compiler has no support for this at all, right? It would just be, if you want to have literals in code, you would have to cast them to either in 128 or basically have a very long. Yeah, I guess you would have to either cast or effectively call the constructor explicitly, right?
Right. But as an example, I was saying 1, 2, 3. So theoretically, if you were to write like a single 128-bit integer that represents min value, you would write it like this. If you have the constructor and you want to write the same thing and we order it upper first and then lower, then you would write it as this. So it's the same thing. It's just you put a comma in the middle and it's still read left to right, most significant bit to least significant bit.
I see.
Yeah. For people on the stream, that we're just typing in chat right now. Sorry, you can't see it.
I can post it to YouTube as well.
Well,
Okay.
the stream is done, right? Because my
okay.
Never mind.
My thing died, but I will upload the recording later, so it's fine.
Yeah.
Okay.
I think the question is like, so, but the literal won't work in C#, right? Unless the compiler does work and says,
right,
we support like 128-bit literals.
There won't be actual literal support. It will be effectively the user has to write a constructor and then the JIT will turn it into a constant.
Gotcha.
Yeah, and this doesn't preclude us from adding literal support in the future, like I-128 if we want.
Right.
Yes.
Okay. So it sounds like we're probably set on flipping those two parameters and do upper before lower because it reads better from the call site.
Yeah, I think that'd be the preference. And then otherwise, everything's identical to int64. I have a call out that anything that differs between this proposal and the generic math proposal that's shipping is unintentional and just a side effect of when this was written versus updates in between. And so really the only new things are the constructors and the conversion operators. And like I mentioned, the only difference on the conversion operators is the conversions to floating point types is explicit because it is technically lossy. And that will be visibly lossy for anything above 2 to the power of 53 for double and anything above 2 to the power of 24 for float.
Sure. I guess my final questions then are, how do you envision people getting the upper and lower components? Shifting or using accelerators like .upper, .lower?
Realistically, they shouldn't need to access those. And if they do need to, then they can they can get the underlying bit representation and access it.
Okay.
do they get that?
Realistically, you should treat this exactly as a regular integer and just use the built-in operators for everything that you need.
Sounds good.
How do you get the underlying representation?
Well, if you just want the lower 64 bits, for example, you would just cast to int 64.
But if I want the upper, I would shift by 64 and then cast.
Yep.
And
then, covering the earlier ask of like, what about changing convert or bit converter or anything like that? That kind of falls into we can look at binary reader and bit converter and etc. As appropriate as user requests come in. The most important thing is kind of just getting the base type and support approved and out there, and then we can always version it over time as appropriate, because I doubt there's places where it needs to touch the entire BCL at once.
Mm-hmm.
Yeah, I mean, there was another question, like, what's the scenario for these types? It's just I have really large numbers, or is that something that is just required for other scenarios right now?
Right. There's so int128 has hardware acceleration, and so one of the most common things is that the underlying hardware for things like 64-bit multiplication, there's actually an option to return a 128-bit result. Likewise, when you're doing things like big integer arithmetic, one of the most common things for detecting overflow is actually to do, for example, int plus int equals long, and then check if the long result is greater than int.max value. And in native compilers, that pattern will actually be recognized and converted to add and then add carry, rather than being an actual compare and branch. In the same vein, int128 allows the same hardware accelerated scenarios to be supported for 64-bit values. It allows you to correctly expose and support the larger multiplications needed. We actually emulate int128-bit types for various floating point parsing algorithms. Math exposes some operations that allow you to do big multiplication and get the upper and lower halves. Then there's things like GUIDs, or bit patterns where you actually just need those extra bits available, and it overall simplifies the implementation by having the larger set there and accelerated.
Makes sense. But that also basically means we can do what you suggest, right? We just just have the types, and then we can incrementally add support in other areas that we would need. But it seems like getting access to the underlying value would be useful.
Right.
But I guess casting and shifting is fine for now, right?
Right. Which is exactly what you're expected to do with int64, for example. If you want the lower 32 bits, then you cast int32. If you want the upper 32 bits, you have to right shift and then cast.
Yeah, I think that makes sense. Will this work with vector? Does half work with vector? I don't remember right now.
So half, there are vectorized instructions for half, but we don't expose them today. That's a broader, there is an API proposal. I don't think it's actually marked ready for review yet, but there is an API proposal to expose the appropriate half vector support. For int128, there isn't actually hardware acceleration in the vectors for those. There isn't, for example, a vector 128 that just holds one int128, nor is there a vector 256 that holds two of them. The closest thing you could do is you could accelerate like and or in other things that aren't actually element wise. And so
right.
we wouldn't ever really support int128 with the vector types.
And that makes sense. I guess one scenario that I could imagine people having is wanting to take a an int 128 and turn it into a vector 128 of int 128, and then immediately turn that into a vector 128 of, say, byte or int or something. And I wondered, you had mentioned using unsafe.as to do that in the past, but would that be appropriately accelerated?
Yeah, unsafe.as could be. There isn't really an accelerated form for going between the vector register and the integer registers. So it would go through memory, but that would still be, basically as efficient as that could be.
I see. So there wouldn't be like an unsafe create equivalent.
Right.
Okay. Yeah, I'm asking because I know that you've been paying a lot of attention over the past few years to the coding patterns that we would expose to our customers in order to make this as efficient as possible. And I would just want to make sure that the API patterns that we're telling them to do, unsafe.as if you need it, would be as efficient as we could realistically do.
Yeah. I think one thing that comes to mind is like, what happens if I put this in something that is being serialized? Because right now there's no public fields or public properties, right? So unless the serializer intrinsically handles those types, it won't serialize at all, right?
Serializers are responsible for understanding primitives. And this is a primitive.
Yeah, and so they would be responsible for getting the underlying bytes, or shifting out the underlying bytes as appropriate. If you want to do reverse Indianness, that's pretty simple. You just extract the two halves and then decide which one to write first. And even internally, the implementation is going to have a if big endian, then upper is the first field, lower is the second. If it's little endian, then lowers the first field and uppers the second field.
Right.
Yeah, because we didn't add any, we didn't mark system.half serializable, for instance. We didn't build any special knowledge of that into older serializers like binary formatter. But system text JSON natively understands it, I believe, because they special case it as a primitive. And we would expect them to do the same here.
Right. Yeah, I was just mostly asking whether we should file a tracking bug for that.
Yeah,
otherwise it will just explode.
We can definitely file tracking bugs for any of this stuff as appropriate. And we can also expose tiny API proposals for things like, do we want to support, a direct reverse endianness API or anything like that? For that one's in binary primitives rather than bit converter.
And you said there's no compiler support needed at all right now, right? For nothing.
Right. With the advent of user-defined checked operators, we can provide the same level of support that half has, which means that we are in the same zone of minimal breaking changes if and when the compiler decides to add support in the future.
Cool. And the interfaces that you implemented is already the math ones, right? They're already
right.
And the right ones.
And with the call out that any changes we make to generic math will be implicitly reflected in these interfaces here and the API surface. So I think one example was the last API review. We said that sign should return int rather than the same type.
Yeah.
And so this one should actually just be int here.
Didn't you say that most things should just be constrained to inumber, but it doesn't implement inumber, right?
It's
binary isign number, yeah.
Binary integer itself inherits from inumber. And yeah, so
that makes sense then.
That's the call out I listed here. The general inumber interface support should match any decisions made for the actual generic math API proposal and be consistent with the other types. Any inconsistencies are unintentional and just due to timing differences between when one was written and the other was updated or reviewed.
Yeah, thankfully the interfaces will enforce that they're consistent. And being consistent. Yeah, I mean, everybody happy with that?
I think it's a solid proposal. I mean, we're going to have to come back probably in a few weeks or a few months and maybe add some supporting APIs around it. We had talked about binary primitives. We had talked about interlocked, system text JSON and so on, but I don't think it affects the type shape itself as proposed here.
Yeah.
Is the only change that was suggested just flipping the parameters on the constructor? Was that really it?
Yep.
Yeah, that's why I was asking, is are we happy with
Okay.
it? Because it seems a bit...
Cool.
And of course, for a 20-day-old proposal, it's got a ton of likes and upvotes and rocket ships.
That's because you have your fan club.
This one was actually surprisingly not the fan club.
Oh, wow.
It's just been a long requested thing. We've had various API issues tracking this for over 6 years now, and we've just been having to say we can't do this yet.
And now you can because of the features that you've been championing.
Yep.
So hooray! Is this something that ships in preview, or would this be like a proper supported thing?
The discussion I had with Jeff was that it would be great for us to ship this alongside generic math and .NET 7. Okay. But it largely depends on timing and how much feedback comes after build for the generic math stuff. So if not a lot of feedback comes back, then this is actually relatively simple to implement overall. It's fairly straightforward. Even JIT acceleration support's not that complicated because we just extend the what is currently the type long to type int decomposition to be effectively type int 128 to type long decomposition on 64-bit. So it's not overly complex, so I don't expect tons of work there. Okay. But what I foresee to be the worst case scenario is we get it all implemented, but not 100% accelerated in the JIT. And then in .NET 8, we go and finish the acceleration. We finish adding maybe things like binary primitives as appropriate, etc. But the API surface wouldn't be impacted or anything. It's just perf improvements release to release.
Okay. Yeah, and if you really wanted to make it experimental, right, it would be very straightforward. Just apply the attribute on these two types, and then that would pretty much be it.
Yep.
Maybe there's some other APIs that we added support for that would also have to be marked, but by and large, that would be it.
Yep, and the analyzer would flag those if those had come up and these ones were marked.
Exactly. All right, then it looks like we have built enough muscle memory to actually evolve core functionality like this, which is kind of cool.
Yeah, that's awesome. Remind me, Tanner, are there checked conversion operators as well? Yep. I don't see them on the screen right now.
Here's one, for example. Oh, yeah, you can't see my screen anymore.
That's a good point. I don't think I listed them here. There would be checked for the explicit operators. Okay. It is impossible to find them for implicit because that's a misnomer. Implicit conversions should never overflow.
Right. Okay, cool.
And so implicitly there would be checked versions for all of the explicit ones where it's possible to overflow.
Okay.
The team has forgotten my mute settings. I know all the chats are pinging again.
How long will it be until someone wants to back an enum with an int 128?
That one would need runtime support.
Yeah.
Okay, I'm going to stop presenting, and then Imo can probably present again, unless you'd prefer I keep presenting.
It's fine. Either one works. I mean, you technically the runtime supports double and float, right? I'm sure somebody has done that.
Actually, so technically the runtime supports it in its implementation, but the spec disallows it.
Which one? The more than 32-bit or
No,
more
no,
than 64-bit?
So float and double as backing for enum. Technically, the spec disallows it, but I think the runtime allows it anyways because it never added that check, and C# didn't allow you to define it.
Yeah, that's what I was expecting. I mean, I'm sure somebody has that running somewhere, and it's
Yeah.
terrible.
Oh, I've seen people abusing the fact that the runtime doesn't always check the backing type of an enum, and I saw somebody back in enum with like some random struct once. It was very sad.
Random struct, now that's even better.
Yeah.
As one does.
We have since fixed that bug.
All right, so I think now we have the extension ones, right? If I remember correctly? Or was there one more? I don't know. Are you done with, or was there one more?
We had talked about zero memory, right?
We also didn't finish approving the other compare exchange PR.
No, that one I did when I joined, because I was about to click comment when my computer crashed.
Yeah, the buffer zero memory one, Levi and I could cover. And then there's two of them that are language related that if we could just get off the backlog today, that'd be great. It's the ref span constructor there, and then the runtime feature for int pointer. Yeah, that one. And then I don't think I personally have any others that are .NET 7 impacting.
All right, so API proposal for this one.
Yeah. So Steve, I guess.
Sure. So C#11 is very likely going to be adding better analysis around passing refs around in support for better support for ref structs. And as part of that, we can safely expose a new constructor on span such that the compiler, sorry, I should have said ref fields in ref structs, such that the compiler can tell, basically taint the span. If you pass in a ref to something that is only on the stack, then the compiler will be able to say, okay, well, this span's lifetime is tied to that ref, so it can't allow it to escape. And in doing so, we can do something that's actually pretty common, which is enable you to create spans that represent a single item. And if you look at our use of like memory marshal.create span inside .NET runtime, about half of them were passing in (1) along with the ref to basically say, I want to create a span for just this one item. And this basically formalizes that. So we now have these constructors internally. And this would be about exposing them publicly once that compiler feature is available. Because the compiler feature will basically change, it involves a breaking change to the meaning of ref, essentially, that it should be tracked. So basically we'll be adding this once that meaning is in place.
So basically this would take one item, and so the span represents this one item that you pass per ref.
Basically, it'd be like saying memory marshal.create span ref item, (1).
Gotcha.
But with the additional tracking that prevents you from then, returning this span out of the method, but pointing to something that was stack out.
So today the compiler can't track that, or the compiler is overly? I think the compiler
now is overly because there's no such thing as a ref field today, and so there's no way, and you can't store a ref onto the heap. That you can't store one of these things, at least not in safe code. So there's no tracking to be done. The moment you're allowed to store these, now the compiler has to start caring about safety.
And so these things are helping with that, or it's just convenience? That's the thing I'm not entirely.
These are convenience APIs that we can now expose safely. Before the compiler added that tracking, we couldn't add this because it would be an unsafe API.
Because as soon as you do that, the compiler says, oh, no, it's a regular span, and so you can return it.
Right. So that's why we had pushed all that support off to memory marshal.
Makes sense.
Then it's, it's on you. I think the only other thing here that might change potentially, I don't know if it would be in C#, or if it would be in .NET 7 or beyond, is there's a proposal that Jared had made, and then somebody else opened it in C# Lang to allow for using read-only ref instead of in signatures for parameters. And we would choose to use read-only ref here instead of in, if and when we could. The distinction is basically whether it would require you to write ref at the call, or write ref at the call site, which then prohibits the accidentally passing in an R value, which using in won't prevent.
I think in this case it might be
read-only ref. Is it not?
Say again?
I thought in is just short for read-only ref, is it not?
It's go ahead. Go ahead, Tanner.
I was just going to say, so in is a read-only ref, but it allows an R value, meaning that you could do new read-only span and then the literal 5. And the compiler will implicitly create a local, assign the value of 5, and then pass a ref to that implicit local. That is fine and good for many cases. Like com interop, even in C and C++ uses GUID ampersand, which is an implicit biref of sorts. It works just like in does, but that's undesirable for some of our APIs where we are directly dealing with memory. So, for example, unsafe.isNullRef, we explicitly decided not to use in because users passing in R values like the literal 5 is problematic and likely a bug in what they're doing. There was just too many places where if the user forgot to explicitly specify in, they were likely doing the wrong thing. New read-only span for an R value isn't technically incorrect. There's nothing fundamentally problematic about it, and it's potentially what the user wants. So for read-only span, it just comes down to do we want the users to be explicit there or not? And it's probably better to lean towards users should be explicit for this case. Make sure they're doing exactly what they want.
It also creates a parallel between span and read-only span where you have to use ref with both.
Yeah.
I guess I was following everything you were saying, Tanner, up until the conclusion, because for read-only span, I don't see a problem with someone passing in an R value.
Right. There's nothing theoretically wrong. It's just the user is potentially not doing what they wanted, and there's the consistency that Stephen mentioned, where you have to specify ref in both locations.
Okay.
I guess my question was is there can you even it sounds like what you're saying is if you declare it as read-only ref, that's different from writing in because the metadata encoding is different. I was under the impression the metadata encoding is exactly the same in both cases.
No, the metadata encoding will be different because they have to be disambiguated because the ref read only will warn if you pass in an R value under the current proposal.
To be clear, this doesn't
which
exist
I linked
yet.
to in chat.
This isn't a feature yet. So
right.
Yeah.
Oh, read-only ref doesn't exist today. You're basically saying the only thing you can do today is in or ref.
Right, and there's a proposal being championed by Jared to also add ref read only so that you can disallow R values where that's important, and also to cover the missing compat story, because changing from ref to in is currently source breaking today, and binary breaking for virtuals, but that's not largely important for the BCL APIs. But the proposal also covers the ability to change from ref to in, or from in to ref read only, or ref to ref read only in a source compatible way.
I'll also say that from adding these internally and using them internally, it looks really strange, at least to my eyes, to see new read-only span local, or new read-only span by. You know, I mean, maybe this is I know too much about how span works and that it is a wrapper around a reference to something in a length, but I see that and I think it's passing in a copy, and I'm like, what is this doing?
Yes.
And you can still write in at the call site, which we do, but without the in, it just looks confusing.
Yeah, I get that. I think that.
Anyhow, this is the best we can do right now, and if we could get a read-only ref, we could change the in to the ref read-only rather. We can change it, and it should be non-breaking.
It's called ref read only. Was that, or read only ref?
Right. It's I linked the issue in chat. It's C# lang 6010. Uh, 60, not 16.
It wasn't overly optimistic how many issues we have, I guess. Sense to me. All right, another runtime feature.
Yeah, so this one is as per the API review LDM offline discussion, and then the following summary that was given in the last generic math API review. The language is going to the language opted to change over to make int pointer and inint, as well as uint pointer and inuint consistent. They're going to do that via runtime feature flag. And so if you are, for example, using C#5 and targeting .NET 7 or newer, you will see the change provided that this feature flag exists. And so this is just suggesting we add a feature flag to cover that, to cover the language need. And so it's just proposed to be numeric int pointer.
I mean, it seems fine. I mean, I probably would have named it slightly differently, like treat in PTR as an int or something, but I mean, it doesn't really matter. It's just a, a flag that nobody will ever read except the compiler.
Yeah. And as long as it's clear enough for the compiler and not conflicting, I think that's fine. That's why I didn't. We tossed a few ideas back and forth in Outlook, but there weren't any potentials that were like, oh, this is a clear winner.
I agree. All right. Easy. And then this one here, right?
Yeah, we have APIs hanging off a buffer right now that allow you to copy native memory. These APIs take pointers, source, destination, and the amount of memory that you want to move specified in bytes. We don't have an API that lets you clear memory. The way that you would normally do this is new span of byte, pass in the pointer and the length, and then call clear. But span right now is limited to int.max length. And there are scenarios, especially when you're working with large data sets, where, well, you might actually have more than 2 gigs of data that you want to clear because you have 2 gigs of data. Sorry, you have more than 2 gigs of data that you're handling. So this API would allow people to write their own memory management functions, their own, like my span type, which is appropriate for my scenario, for instance, which might also be more commonplace as people introduce ref fields into their own types. So this would be a helper method for that, basically, for them to implement clear. This would only work because it takes a void star as a parameter. This would only work with unmanaged types. So you can't say I have 10 gigabytes of person, and then I want to zero memory person, because you can't ever take a person and cast it to a void star.
Right. So the questions that I had on this was mainly, should we be providing a basically a ref T overload, because you can zero any memory safely by just assigning it default.
I don't think we tend to include ref T overloads outside of things like memory marshal. If we did want to add one as a helper, that's probably where I would recommend putting it.
That's fair. And the other bit I was going to touch on is so for these memory APIs, we currently have, 2, maybe 3 locations where they exist, and sometimes it's hard to remember which are where. There's system buffer, there is system runtime compiler services unsafe. We now have system runtime interrupt services native memory, which that one's actually contracted to be basically a direct call to the underlying C runtime APIs. Are we exposing the right API in the right location here? Would it be better to basically expose zero memory or memset in that basically guarantees the C runtime API rather than being a potentially implemented and managed? Would it be better to have this in unsafe and have it, because we already have a NIT block there, but that doesn't cover sizes up to inuint. It just covers sizes up to uint.
Well, that's because the init block instruction only handles up to in 32. And I think in the past we've said that the unsafe class should very specifically be something that correlates directly with an IL instruction.
That's fair.
I think to me this would largely depend on whether we want to have logical or actual overloads that wouldn't be requiring unsafe because they're not dealing with pointers, but it would be unsafe. So because I think putting them on buffer would be fine if they require unsafe code to call already. But if the APIs themselves don't require the unsafe keyword but are unsafe, then I don't think we should put it on buffer. We should put it somewhere in the typical unsafe places like memory marshal.
Yeah, the thing about ref T is you'd probably still want to limit it to unmanaged types T, because you can't ever really have, again, like an array of people more than 2 billion elements. Like that's just not something that makes sense from the runtime's perspective.
And so you're saying that those users should just use span.clear?
Yes, because that covers every scenario that's possible in today's runtime.
Aber es ist gut.
Sorry, Joe, you broke up.
And disconnected?
That's fine. May have just been a false hit. Yeah, so for the only reason I could think of maybe wanting to take a T is to say like, well, I have my custom native buffer of 8 billion shorts, and the runtime can do the math to say, oh, that's actually 16 billion bytes. But you could always just do, times size of short yourself.
Yeah. The biggest benefit of having the ref of T is it avoids the need to pin for very large data, which we've actually found to be beneficial in our own vectorization APIs. Because because when you pin very large data, you're more likely to end up having a GC that may want to move that large data or move around that large data.
But when you have memory of greater than 2 billion, when you have a buffer of greater than 2 billion elements, it doesn't end up in the movable heap anyway.
Yeah, that's fair.
So again, that's a scenario that would be covered by the existing span APIs.
I'm laughing because Jared just set me straight on what the keywords were in Midori, and they're very funny. I think we should have them as prefixes for unsafe APIs.
Excellent.
That would. The conclusion is basically we don't want to do it for managed types because arrays are not larger anyway than span. Is that fair? Or
it's because span of T already covers every scenario that you might have with managed types T. The only thing that the only scenario this actually enables that would be difficult to do today is unmanaged types T in memory that is already pinned because it's not being tracked by the GC.
Well, you could still do it if the buffer is smaller than 2 gigs, right?
You could, but why would you? Just use span and be happy.
Yeah, I guess that's my point, right? So like you could just say new span of byte pointer comma length and then call clear, right?
Well,
whether that's pinned or not, right?
Well, yeah. Sorry,
span's only up to int dot max value, so this covers you have more than what can fit in a span.
Yeah, that's kind of what I'm trying to say. So basically, the only thing that this API would enable is the more than array length memory, right? Which would not apply to managed types, basically.
Right, and at that point, I'm wondering if exposing it on buffer is better than exposing it on native memory and just saying this calls down to the known efficient C runtime implementation. Basically just contracting that it's going to do that.
And that seems fine. And I mean, then we would never need any other overloads because we know that it's always going to be a pointer.
Yeah, and I don't really care what it does from an implementation perspective. The contract would just be at 0 as a buffer.
Yeah, I don't know, like, what would the C runtime guarantee you that, I mean, you get 0, so not much to guarantee.
It's just a efficient implementation. It's kind of like, you know, we put the native memory APIs there for alloc and stuff because we wanted to have the guarantee that the users could call free accordingly. But that then gives a centralized place for saying, I'm working with native memory. And therefore I want to conceptualize this as basically the kind of the very few primitive memory operations that are exposed in C. I don't have a strong preference there. I was just suggesting it as an alternative.
I mean, it makes sense. I mean, the question is like, if you use this API with raw pointers, I mean, if you very likely to already use native memory anyways to get the memory and free the memory, then it would make sense that that's where you also zero the memory, right?
Yeah, and I agree with that because if you're dealing with NuInt, you're already in a world without span. Because if you already knew ahead of time that your data fit into a 2 GB buffer, you just would have stuck with the managed APIs in the first place.
And buffer's somewhat of an odd API today already because, you know, it exposes block copy, byte length, get byte, and set byte, which only work on array. And actually the only unsafe API it exposes is memory copy. And that API for memory copy isn't even like an efficient memory copy. It forces you to take long rather than native integers. It's got a weird API shape compared to like what you traditionally want for a mem copy like API.
Mm-hmm. So you would call this native memory .0 or native memory .clear?
Yeah, memory 0 or 0 memory. I think the Windows API is just called 0 memory.
Yeah.
So is that capturing what we said? Yeah, it also answers my other question because I mean the other overloads on buffer don't take NUIN today. They take basically in 64 variants
Yeah.
And everything on
Yeah.
native memory already takes NUINT, so it makes a bit more sense.
Yeah, native memory, the parameters are called pointer, PTR, and byte count for most of the APIs.
Yeah.
Yeah.
So we'd probably want to keep that for consistency.
It's actually funny now that I guess I updated my version of Roslyn that I use for API catalog, and now everything shows up as NUINT, but when they actually render out the text, it shows up as UINT PTR. So there's something really weird going on. But yeah. With the new version of the runtime feature thing, it will always be UINT PTR.
And this also would set precedents for if users come in saying, hey, where's my memset API that works over native? We have a place to go. Same with memcopy and memcompare, or even memmove. But those are like that's the full set of memory APIs from C.
Yeah.
Looks like the only thing we now need is support for the delete keyword, and then we have full parity with C++ as well.
No,
Were you
we need RAII. It'll be great.
No, we've got SAII, static abstracts and interfaces.
Oh yes.
Were you going to change the name to pointer and byte count to match the other APIs, Mo?
I can't do that.
Yeah, pointer is PTR because that's what we did.
And the other one is size
Byte.
of bytes still?
I think it's byte count.
Yeah, byte count with a capital C.
As opposed to C, where it's just BC.
Yeah.
Yeah. Because apparently in C you pay for characters. Or as they call it, chars.
No, they're cars because they're narrow chars.
I see. All right. So then at this point we're done with everything kind of wanted, right?
Oh,
Yeah,
surely not.
That's at least, I think, all the API proposals I can think of that were impacting the language or that were in my specific area. And like I said earlier, if anyone else has any others, feel free to call them out.
I think Eric wanted to do some extensions, but for some reason I can only find one of them now.
Yeah, Miriam dropped the other one. I was
Gotcha.
unaware, so we just have one now. So
All right.
are we on this one?
Yep.
So in DI, we have a service collection, which this is the thing that you add your implementations to, right? You say, I want this one transient, this one singleton, whatever. And then you build your service provider from that service collection. And as part of like the new minimal APIs in ASP.NET, and then also kind of the clone of them in Maui, we expose the service collection on like the builder thing. And when you're done building, the service collection needs to be read-only because you can't add more services once you've like built your app. And so what's ended up happening both in ASP.NET and in Maui and probably other places is we had to make this kind of wrapper adapter iService collection thing that has a service collection inside of it that we add the stuff to, and then we make read-only, and we only give out the wrapper collection. And so anyway, like the idea was, well, if we could just make a feature on the base service collection, make read only, that it would throw if you tried to add more things to it after make read only is called, that we wouldn't have to do all this extra adapter stuff in all these other app models. So the ask here is to make a new method on service collection. I don't know if there's like a normal way of doing this, but like called make read only, that once you call that, you can still enumerate it and things like that, but you can't add things to it anymore, add or remove.
I mean, we do have that pattern in other places. I think in WPF they have that as well. That was one of the design points we considered originally before immutable collections. Basically have them mutable and then you call a method and make them immutable from there on. But I think in WPF land they call them freeze. But I don't have very strong opinions because I don't think it's that common of a pattern in the BCL. So it looks like we have already other methods called make read only. And I think in general, frankly, I think the name is better. It's like, maybe it's just me, but freeze seems too much of a lingo thing and not really clear what it does. Versus
Yeah,
this
looks
one is
like
pretty
secure
unambiguous.
string has a make read only.
Yeah, all the stuff in identity model apparently uses make read only. So I mean, naming wise, yeah, the WPF one, there's only a few places. I mean, I call them, I think, freezables, and then you can freeze them, and it's very weird. Yeah, unless somebody feels very strongly about this, I think the name is fine. I also think, I mean, as a general pattern, I think it's also fine. It's like we have this elsewhere in places, right, where when you have a type of a bunch of properties and then a method that after you call the method, you can no longer change any properties. So that where that's kind of like the make read onlyness is basically implicit. Once you start using it, it basically becomes immutable. But this would just codify that.
Yeah, I mean, the unfortunate thing is on service collection, you don't have the build, if you will, right? It's like an extension method, depending on which DI you're actually using. And so, yeah, there is no like, all right, I'm done adding, now I'm going to do things with it. So if the build was there, then yeah, you could just say, well, once you build it, then it's read only, but we don't have a method on it yet.
I mean, technically it exists as just another type, right? It's the build, right?
Yeah, the build exists, but it's an extension method on like the DI implementation, because the thing you're building is going to be like either the built-in one from extensions or like autofac or Grace or all the other DI.
Oh, I see what you're saying. So it's not just us who have to call it. It's like anybody else who effectively provides a DI system would have to call it too. So we can't make it internal and just call it ourselves, basically. It would have to be something public.
Right.
But the user generally doesn't call it. It's just somebody else calls it. And then the user just observes that they can no longer mess with the service collection.
Right, exactly. Like in ASP.NET today, you already get this behavior because the service collection that they give you from their builder is one of these wrappers that once you have called build on your app builder, it starts throwing if you start adding things to it. This would just move it a lower down into dependency injection.
Yeah, makes sense.
So yeah, it really wouldn't break anybody, right? It wouldn't be a breaking change. It's just.
Oh, somebody's probably broken by the fact that you return the same instance, right? Because that's how people's code works. But yeah, I think it makes sense. Anybody else any concerns with that? No? So then that's easy.
Thanks.
All right. And just walk them in order. This one we skipped because they want to do it next Tuesday. Anybody context on this? Who marked it? Yeah, I think.
Yeah,
Steve.
I have marked it. Can you hear me?
Yep. Go for it.
Yeah, so it's not exactly like new IPA proposal, but so we have if we ask for the generic attributes with the closet type, we can get the attribute, but if we ask for attributes with open generic, right now it would return an empty array, and he is proposing to return all closed generics when there is an open generic requested. So as it's requesting all closed generics for open generic, the API review, and there is some interesting scenarios the committee member asked about how it should work. If we want to cover derived attributes, etc.
So I assume the idea would be, you can't really apply an open generic, right? So the attribute application would be some specific version that is instantiated, but this way you can say, give me any instantiations with test attribute.
Yes.
I mean, that makes sense. Is that the only API that would have to honor this? I mean, there's various ways you can ask for custom attributes, right? We have it on attribute. There's some extension methods we have, I believe. I'm not sure how they're calling into each other, but I mean, logically, you probably want the behavior that whenever you can ask for custom attributes of a type, you would support open generics, right?
Yeah. Should be applied for overloads with the type attribute type. That's is a parameter.
I assume nobody has any concerns with that idea. Then I guess it's approved. It's just, I mean, I would just treat it as a bug fix work, honestly, because it's no API changes. But it makes sense as a scenario.
Go to the comment member, ask about the behavior, like derived attributes a little more up. Here you go. Yeah. So like in this case, if we expect to derive from generic attribute, that one.
Sure. Yeah, I think that I don't know exactly what. So what's the behavior that custom attributes do today for derived types? I think they would return the when you ask for the base ones, they would return the derived ones as well, right?
I think there is a Boolean parameter that says derived to. I think that is by default false. I'm not sure, but if that is true, then we return the derived ones.
Yeah, I think you're right. I think that sounds familiar. I've not done this in a long time, but yeah, exactly. Yeah, there's a bool inherit that you can ask. So I would say, yeah, it should honor that as well. And it would make sense that, you know, the open generic would be matched by that as well. Alrighty. Any other questions?
Yeah, thanks.
Sweet. Did everybody drop off? No. Okay, there's more people on the call now. For a moment, it looked like it's just me. I'm like, hold on. Anybody context on this? As we set up a meeting with them. Doesn't sound like it.
I think Jared wanted to be here for this one. I just pinged him since he's talking in chat every now and then. But he's yet to respond to say if he does or does not.
Yeah, we can get to this in a few minutes if he swings in.
Oh, they're in stand up right now.
Yeah.
Jared can join after stand up in about 10 minutes, so we should be able to get back to it.
Good, and let's do that. I mean, that seems like a very reasonable API. Yep, and the alternative design answers my very obvious question, but So anybody any issues with the APIs that's being proposed?
Seems reasonable.
My only question is, I mean, I know it's covered in the alternative designs that you were just talking about, but is that statement different from everything else that's exposed on GC memory info? Like, pause time is special because we have a faster way to get it, unlike all the 17,000 properties that are currently there. I'm wondering why this one's special.
Well, I guess generally speaking, you're okay with the overhead for memory info because these numbers are all somehow correlated, right? Versus this one presumably would be independent of those things that are on memory info, right?
I don't know. Is it?
Yeah, looking at it, maybe not. It says pause durations, pause time percentage.
I'd presume that maybe this is just something you want to query more frequently, but even that seems like maybe if you were doing this per frame in a game or something.
Can we make this that fast?
I believe the GC is implicitly tracking the pause time already.
Yeah, if the GC is just updating some memory address somewhere, then we could just make this a read into that address.
I mean, presumably when you call memory info and you just add up the pause durations, that value is identical.
Well, I think what they're saying is that you would have to get the percentage time spent in GC and then call like system process get current process something, and then get the total wall time of the process execution and then multiply them out.
Well, they already have a pause durations read-only span of time span on GC memory info. Isn't that just the sum of those? I don't know what else it would be. I guess pause time percentage would be what you said, but that would be, yeah, you would have to basically, since process start time, the double should be the same value, right? So I guess the question is, you can already get it from memory info. It's just you would have to pay more for it than you probably want. But yeah, I mean, I think Steven's larger question is, are we now basically having dedicated methods for everything that's on memory info because we're no longer willing to pay the price for the whole thing? That might be a bit of a problem. So do we want to ask the question first, or does anybody feel strongly enough that we should approve it as is, just with the commentary, or should we wait back for a response and then decide based on that?
They're coming on Tuesday to do a more in-depth GC stuff, right?
Yeah, you're right, actually, yeah.
Yeah, so I think we could just wait until Tuesday and say this is like tentatively approved unless they say that there's like no actual need. We could just get the quick question answered.
Yeah, I can just pause the questions and then leave it as is.
Yeah, because what I'm concerned about then is if there is a way off of GC memory info to get this data, but GC memory info is seen as too expensive to get this data, like, does that mean that we've messed up the design of that type?
I think it also comes down to how much of the data you want. Like if you just want one property, then it's going to be more expensive to use the memory info API. But if you need most of it, like because like you're generally tracking all the telemetry, then it's going to be faster to use the memory info API.
Well, it's not just faster, right? I think it's also the fact that these things are related to each other and snapshotted, right? If you just have individual methods, you always get, them individually snapshotted, but then you can't relate them in any meaningful way, right? I think originally the proposal was that they're all independent things, but then you can't, use them in conjunction. But I guess things like total pause time, I mean, it's the total pause time, right? So there's not much to relate to it. All right, so let's look at this later then. Yeah, I think this one is also scheduled for Tuesday, so we can skip that one. Same with this one. Anybody context on this?
Diagnostics, would we want folks like Jeremy to be here for this? Do we have representatives from diagnostics here right now?
I believe so. Over it.
From what I'm reading, it's there to support hot reload.
Yeah, that's what I was thinking, and it seems like it's just tracking you rename to type, right?
Yeah, it would actually. So more broadly speaking, this is like an attribute that covers renaming a type over time, which is something more broadly speaking. I almost wonder if there should be a language discussion on should the language support this as well. Because we've had the discussion about parameter names and other types of forwarding.
Well, this wouldn't be forwarding, right? Forwarding we already know how to do. This is more, I think, without reading it, it seems like this is the general problem where they can't replace the type in place, so they emit a new type. And then I just want to indicate that that's basically, a new version of the other one, which I think wouldn't be actual forwarding at runtime. It would just be for framework code, I think, to find the latest version of that type. But that will be, I think, some questions we should ask. Yeah, this is basically it. Yeah, I mean, I think I know what it's for. It makes sense to me, but we should probably have a conversation with them. All right, what these guys here? Anna probably has context on this.
Yeah, so this one is basically that we've got various safe handles for that exist in reflection, and it's basically just asking for a way to be able to get a raw int pointer to and from those. That way you can more easily do various types of interop or performance related work. And it's calling out this is an already internal API we use in various places, but
makes sense.
Just asking for it to become public so everyone can use it with examples of how it would be used.
Yeah, I mean, these seems fine. I mean, I would even be open that at least one of the directions could be an implicit cast as well. That seems fine as well. Like casting a runtime type handle to an in-PTR as an implicit cast seems unproblematic, right? But I guess it depends on the shape of the APIs and whether it's actually useful or not. Presumably nobody cares enough.
Could you repeat the question?
So, like for me, the direction from the strongly typed handles to the in-PTR could also be an implicit conversion, right? That might be more convenient.
I don't think we do that anywhere else right now. Like we don't do that for GC handle or safe handle or hwind or anything else. Those are all just explicit because you don't want to accidentally pass it in where you wanted like an actual opaque handle or anything.
I see.
Make unsafe code slightly less error prone by forcing people to be explicit.
Yep, that seems fine. Basically, all the other ones was the GC handle, is the one you called out. They have those names, I suppose. Well, only for GC handle the explicit cast. And there's also a method, yeah. Comment 2. All right, Jared. Sorry, what?
I was just going to say, and Jared's here so we can
Yeah.
do his proposal.
So tell us about this.
So, yeah, so there's one thing that we keep coming up with, a problem we keep stumbling up against in language design is how do we add new features to the language and in such a way that they can be consumed by the BCL, ASP.NET Core, and a lot of our customers, which have strong binary compatibility guarantees, but have APIs that kind of work against the feature we're trying to add. Like one of the most common one, like one of the most kind of common patterns we have is this idea of we tend to want to add these new caller info items. So we recently added like caller info argument expression where you add an optional parameter and we will fill it in with kind of the textual representation of the expression that went into another one. It's perfect for APIs for like debug.assert, where we could essentially say like, hey, like, you know, instead of getting debug.assert false, you get debug.assert like x is not equal to null. Like it's a much better experience. The problem though is we have this weird thing called compatibility in C#. And the way in which our compat rules work out is we will always end up preferring the older version of the API, like the one without the optional parameters. Like you can add this caller argument expression all you want in debug.assert, and we're literally never going to call it because we will always call the one without the optional parameter first, because that's how the compatibility shakes out. And that was how optional parameters were designed. And there are a number of other features like this. Like one thing that came up a lot when we were doing all of kind of the new Lambda inference rules and overload tweaks that we did in C# 10, we found like a whole bunch of APIs in ASP.NET Core where they're like, man, we wish we could use the new rules here, but we can't because you're always going to fall back into this old legacy trap that we have. And we've been discussing this for a long time. Like, how do we kind of rationalize the fact that we have a lot of these APIs out there that we need to have for compatibility reasons, but they're like making it very hard for us to both design and consume new language features. In terms of the design phase, we are constantly faced in language design with, okay, we could like take this new little rule and we can make overload resolution work like this. And then we go and look at ASP.NET Core, the runtime, and we're like, oh dear Lord, they have an API pattern like that? Like that will defeat everything we're trying to do here. Like we can't we have to like make a rule, a little tweak to overload resolution so that like we don't fall into some compat trap with like runtime or ASP.NET Core. And on kind of have the opposite end where we add all these new features and like the runtime team's like, great, you added this feature that we can literally never use in all the places we want to use it. And so we've been kind of struggling with like this for a long time of like, how do we kind of cross this boundary? And like, this is not like a one-time thing. Like this was brought up and we did caller argument expression. We're like, well, that's really unfortunate. Oh, well, and we moved on. And then we have a new one, new caller info identity, where in order to make like our AOT scenarios better, we really need to be able to know what type or member was the thing that called this method. It's very important for like DNI scenario. Oh God, I'm forgetting not DNI. How does ASP.NET Core build all their dependencies? Dependency injection, yeah, DNI. It's important for like dependency injection APIs and things like that. But it keeps falling into this trap of, sure, go add the API. We're literally never going to call it. So one thing we've talked about, I kind of had this idea and that's been circulating around, is adding a way to mark APIs as binary compat only. Like basically saying that we can kind of really make progress in this area if we just said, hey, we know we have this API that we used to call that we just don't want, that is interfering with our ability to make forward progress. And we would like this to exist just for binary upgrade scenarios. Like when you compile from source, we just don't want this to appear at all. We would rather just take this API and exclude it, essentially make it unusable in source code. It is, but the compiler will still process it and put it in the binary so that anyone who is in kind of an upgrade scenario where you like compile for .NET 5 and then started running on .NET 6, like your code continues to function just fine. However, if you rebuilt that code, it would potentially move from the old API to the new API that we wanted because we would exclude it. Oh, so, Levi is getting cute there.
Is the logical, like, is the only behavior that this would basically have is remove it from overload resolution, effectively hiding it?
The idea is that it doesn't exist. So it's not only overload resolution, it's any kind of member lookup. So that means both you hide it from overload resolution, you hide it from method group conversion. So if you attempted to like take a method and put it into say like a delegate, like we would take that out of the candidate set that we are looking at. Sure. Now, in terms of like how this actually works under the hood, we don't fully know yet because we haven't fully designed this. So this is still more in the idea phase. And like, I think a lot of what we want to talk about here is like at a high level, we kind of understand how this is going to work. We will just, in source, it just kind of won't exist. There's a lot of different tweaks we can have on how we pull it out of source, but at a high level, it just won't exist. What I
would not really apply to
want to kind of talk
types,
to the CCL team about. No, not at this point. We would probably start with just methods at the moment. Because those are the ones that we like most frequently run up against. I think it could at someday apply to types, like to use dirty words, like secure string. It is a way to solve that. It is an approach to solve that problem where we say that there is like one more, if we think that kind of the part of the obsoleting story is that you can upgrade, but we will kill your code when it tries to like rebuild on that target platform, and then the next one we delete the type. Like if that is something that you all thought was valuable as a part of kind of an obsolescence deletion like complete story, we could talk about putting that in the language. But the main focus at the start was just types. Just methods.
So can I then say, is the logical model effectively, we would, like you could do the same thing today, but just effectively removing the API from the reference assembly, but leaving it in the implementation. Is that effectively what the compiler would do?
That is effectively what this is doing from the perspective of C#. Now, if you think about other languages, this is the other thing, is like with other languages, they would, you could do that today, and that would be a completely acceptable way of like fixing your thing. However, that causes problems with say like F#. Like F# doesn't necessarily recognize all of the features that we had to C# like immediately as we do it. So if you tried to do this exact same trick of we're going to delete like debug.assert bool from the reference assembly because we want this debug.assert bool and then like the string message, you would really hurt other languages like F#, which has not implemented caller argument info expression. Whereas with this approach, it's more like you are effectively making it kind of a feature that languages can opt into. Like we are, like the kind of suggestion is reusing obsolete API with binary compat only. Like that is something that F# could then say like, hey, that's valuable. Like C# got a lot of miles out of that. Like let's start using that too, VB, what have you. So that's kind of the key difference between doing this as a trick with reference assemblies and a trick with like marking the API as in source. Is like it's better supported with a bunch of languages.
Would you then say then the desired behavior of the compiler would be only remove this API if another API also applies? And if you don't find anything that applies, then just keep using this one?
The compiler would, probably the simple way is we would just kill it, because the problem is once you get into things you're like, oh, like use this and if this doesn't apply. We have a whole lot of if this doesn't apply, try something else logic in the compiler. It's called overload resolution. We do some really fun stuff. It would literally, the impact of this would conceptually be like as you described in a ref assembly. Like it just doesn't exist. Like it's just not a candidate that you can call. And the idea would be that anytime you use this as kind of like the .NET framework authors, if you took advantage of this API, you would be kind of it would be kind of up to you. Like you have two choices. Like we are basically trying to remove an API and add a new one where we expect like 99% of the code will just call this old API can now just easily call this new API and it just won't be a problem. And we can, we can talk about, the rules around that. Or it could be a place where you are deliberately saying we are done with this. Like we don't want this to work anymore and we're okay with some breakage. The power is yours. Now, like what I really kind of want to talk about this review, because like I said, we don't have the language feature implemented yet. It's more of just two things, like understanding like how the shape of this change would work if we did it. Like here, you'll see that I have the obsolete API and I put like a tick for binary compat only. An earlier version of this proposal, I believe I put as an alternate, is you just have a completely different attribute. The other thing is, would you all think this is valuable enough to use? Because if you are like, yeah, we're not going to use that, there's no way I'm doing this work. It's like, this is only worth doing if you all think it's going to enable you all, if you all would be comfortable using it to move to new language features and to like make your APIs better and have a better upgrade experience. Because if you all are not comfortable with it, then there's no point in doing the work.
So one of the things that I put in chat is I think this actually would have significantly more benefit to us if it allows us to overload by return type.
Of course.
And I put in chat a few examples of where we might actually want to do that. The big one being maybe span of t can actually be backed by new int instead of int. Like this might actually allow us to do that.
I knew it instead of.
So
okay.
The length property could return new int because technically it is a different member than an int returning length property.
I think that'd be one we could kind of. I'd have to think about that because that wasn't kind of in the idea I originally had. But I think we could, if you all said this is only valuable if you can change return types, then we could sit down and say, okay, let's think about how we could change return types as a part of the design.
Well, the problem is that you would have to be able to define them, right? Like this, like you have to define basically both members, and then one of them is marked as the attribute, and the compiler would have to also support that. It's not just the consumption, it's also the definition that would have to be supported, right?
That's correct. But I mean, if you think about it today, like we have to support that. Like you can define two members with different types. Like we have to parse it and give you guys decent errors and still produce like a semantic model and give symbol information.
Sure.
It's more about just saying in which cases would it not be an error. Now, I'm not saying that's going to make things easy, but it is. I don't think it's outside the realm of we could do it if we needed to.
I mean, my personal preference would be it's a separate attribute just purely because we may want to have different targets, because obsolete applies to, I think, everything effectively. And this one, as you said, you may want to start with, you can't put it on types because it would be weird, or you would just say you can only do it on members or whatever, right? It's So that's one thing. The other thing is like, I'm not sure we want to like the obsolete experience for those things. Mostly because, yeah, it seems like overhead. Like your particular example here, where it's just, you know, it's pretty obvious on, you know, oh yeah, we have these two things. The other one just gives us more information, so please call the other one instead. There really isn't a reason why we need to write a, you know, a page on why this is obsoleted, right? It seems self-explanatory for the most part. And I don't think we would use it in cases where the new behavior wouldn't be a superset, right? We would probably not use it for things like secure string where we just want to kill an API. It would be like, yeah, if you recompile, you get the better behavior. So that seems like the primary goal we would go for, I guess.
Yeah, and while I think that there's some interesting cases where we could do, we could make changes that are currently exclusively binary breaking today, like changing return types and making it so that it could be compatible and become only a source breaking change. We could effectively make the decision, this is better for the ecosystem, so we want to break users who recompile. That's one interesting thing, but I think even beyond that, just like we have APIs in string, we have APIs throughout the BCL where like even when we eventually get params of span, for example, where even if the language didn't go and say, hey, we're going to say the spans version is better than the array version, we would be able to make that decision ourselves at that point. And so it ties things less to the language in terms of betterness. The framework's now able to make that decision themselves when we think it's better.
Right. I think the one thing that Jared said, which I'm not sure will actually fly in practice, is the idea that it's less impact for the language or for other languages, right? Because I think the problem for F# will be if they want to support one of those scenarios, let's say the caller identity attribute case, for example, and they will start processing the binary compat only thing, they effectively, if they do the same semantics that C# does, which is, you know, they always excluded from name lookups, then, well, now they're basically putting themselves on the hook to support all the features where we did this particular trick for C#, right? So I think it's going to be a binary thing, right? Once you adopt it, you have to adopt all cases for it, right? There is no piecemealing.
Yes, you're correct in that respect. They would have to make the decision to kind of say, like, any of these features which start to kind of impact it, like, we have to do it. Now, one thing to keep in mind, like, if you do start changing return, if you want the one where you're like, oh, we want to oscillate on return types, that will screw with other languages, period. Like, because while at an IL level, yes, you can differ signatures by return type only. I do not believe other languages have fantastic support for that. In terms of like which one would they pick, like how do they deal with that? Do they error? Do they pick one? I honestly don't even know what C# does offhand. I don't know if we mark it as an error or if we pick first. It's probably one of those two. But that'd be one to keep in mind. But like I said, I'm happy to sit down and kind of like people who are interested in this and said, you know, maybe this would be valuable. Like I'm happy to like kind of, you know, sit in a room a few times, kind of walk through like what the decision, like what the options would be, and like maybe try to find a few, like I put the bug.assert down here. There's a couple more. If you click through on Jan's proposal for caller identity, it's the one that's highlighted right there. There are a few more APIs you can see where it's really hard to see what a path forward is unless we have a feature like this. Like I said, I'm happy to sit down with a few people on BCL and walk them through like which directions we could take the feature in and what kind of the implications of that would be, and then we could make a decision on this is valuable, we should go try to pursue it, or we can't see ourselves using this, you know, punt, move on. Like one thing I want to be clear on is like no matter what we do, like if you add this API, there's always going to be an edge. Like you can do a whole lot of things to say that source, which reasonably called this method before, will call this method after we apply this attribute and you upgrade. But there will always be kind of a weird edge case that comes along. Like someone could do some really weird like overload resolution trick. Like if you all want to, for instance, convert spans return from int to uint, I'm sure I can sit down and pretty quickly design some cases, you know, just find the intersection of types the differences between like what can int convert to versus nit, and then just have someone pass link to an overload with that, and you have a break. So there will always be like a small friction area that you will be creating if you did this. I think you can make it extremely manageable, particularly on method parameters. But it is something that it won't be perfect. Like you would be saying that, okay, there is a small subset of customers that could get broken by this. And again, I don't have a great intuition if that is within your all's comfort zone or not, if you think the wins for doing that or not. I mean, I understand you guys do take deliberate breaks every now and then, and I just don't know. I don't have a good feel for where your comfort level is on that type of change.
I mean, it usually is a function of like friction versus cost, right? If the positiveness for us is mostly in aesthetics, because we don't like how things were named, we just basically get over ourselves and don't cause the friction. If it's or it performs much better, or the user gets, most users get just fundamentally better behavior, then I think that's something where we generally entertain it at least, but then it also becomes a function of like how much friction does it cause, right? I think I'm personally more on the, if it's source breaking only, I'm much more comfortable with it. If it's binary breaking, then it's usually like we can't reason about it because the universe is too large for our APIs for consumption. But source breaking, it's manageable. And I think, the way I think about this feature, maybe that's wrong, but if you really basically say there is a way in an attribute to effectively state, hide it from the public API when the compiler consumes it, then it's effectively the same as hiding it from the reference assembly. And I think we know what that means mechanically speaking, right? And if that's what the feature would be, I think that would be interesting, I think, for us to look at what could we do with that.
Yeah, I think we're actually in a situation within the libraries team where we want to do a little bit more experimentation. I mean, look at what we're doing with generic math, right? And we're reliant on new compiler features in order to give us the ability to do that. I think this attribute is another good example of something that would help, lubricate our ability to make those experiments going forward. And maybe the experiments that we do don't work out in the end, but at least we were able to do them. And this gives us that ability.
Well, that's a good example, right? Like if you imagine you want to use this in the context of experimental APIs, or maybe the behavior that we want is, well, if the API is marked with, preview and is marked with this attribute, then, the attribute should only take an effect when the person opts into preview, right? Or something like that, right? Like then it becomes more complicated for the compiler because now it's conditioned on something else potentially, right? That might make it more annoying to implement.
Like putting this on obsolete attribute in particular makes me think that the justification string, the message inside the obsolete attribute will play into this somehow. Like I would expect that most people who would use this would expect it to tie into editor browsable somehow. But I'll leave that to other smarter people to discuss.
It would tie into the IDE, not editor. Like if we did this, the way we would just basically, it would be hidden from the IDE by various mechanisms.
Yeah, in this case though, if I put binary compat only, like I think if I understood you correctly, the compiler doesn't even see it, correct? Or it just ignores it basically.
Well, we have to actually compile and put it in the assembly, but where it becomes interesting is that, and we would have to, for instance, likely if it were a member that was part of like interface, if it was like an interface implementation, we'd have to talk about like, well, do we see it for that or do we not see it for that? Like I said, it's not 100% sketched out. This is much more of a kind of an idea with kind of squarey corners right now.
Yeah.
But we'd have to sit down and kind of like walk through some of that. But the other thing, but kind of like the kind of counter, like I said, this is idea I've had centered around. It seems to have some lukewarm support in various places, but kind of the counter to this is if we don't do something like this, then we have to kind of look at Jan's caller identity attribute proposal and say, well, we got to do something else. Like this AOT, they really feel like that this is something that's going to help them with AOT and how they're going to get AOT forward. But the places we want to use it, we can't because of this compatibility problem. And so we would have to make some decisions on how we approach that. And it could really be as simple as we think that this is too heavy. Like, we don't think this is generally useful enough. So we're going to do the ref assembly trick and just go to those few ref assemblies and just nuke those members. We're going to add an attribute, like, don't put this in the ref assembly, and like tell F# and other languages, sorry, you got to learn about this new feature, and like move on. That's another way to do it. Different friction points, but
if we remove a member from the ref assembly for .NET 7, will .NET 6 applications continue to work, assuming they're running on the .NET 7 runtime?
Yeah, the ref assembly is only valid for compile time.
Yeah, it just impacts source breaking changes. So if we don't expose a member in the ref assembly, then as far as the compilers like C# and F# are concerned, it doesn't exist.
Well, I guess what I'm trying to figure out is like where does it actually cause like a method missing exception at runtime? Because I don't remember if the assembly is actually trying to find, I don't remember if the app is trying to find system.runtime API versus system private corelib API, where it would still exist, obviously.
It tries to find the system.runtime, but then the system runtime implementation has a type forward down to corelib.
Yes, you're right.
From your all perspective, ref assemblies are fire and forget. You fire those off of the compiler and then you forget they exist.
Yeah, unfortunately, that's not true. We have to still resolve the types at runtime.
And then I have to go touch CCI because we have our custom ref assembly generator.
I mean, that's basically the biggest friction for us is effectively we have to, because we try to generate the reference assemblies, we would probably cook up some attribute on our end and then allow it to be excluded from regeneration. So we don't have to keep not forgetting to remove the one line that puts it always back when you regenerate it, right? But I think that's, personally, I think that would be fine if it's isolated to things like call identity attribute, where we have like 2 or 3 things in the framework that need to do that. But it would basically mean, yeah, the F# guys better support call identity or they're basically screwed, right?
Yeah.
But that seems not entirely insane, because I think the feature would be useful enough that would be like, yeah, would be nice if they would do that.
Right. I mean, honestly, that is something we can legitimately discuss, is that an outcome of this may be that, hey, Jared, this was generally, yay, good generalization. We're not going to do it. But caller identity, damn, that's important enough that we need to go and make sure that all of the, I mean, it might be a position that we take that AOT is important enough to the platform. We're going to make a couple of changes in .NET, 8 or whatever, that requires all the languages to understand them in order to properly support .NET 8. I think that that's a completely, I mean, from my peer at least, it's like that seems like a valid thing to do if it's that important for the platform. Maybe something we've never done before, but I mean, I think it's definitely, it's an idea that I'm willing to like kind of keep talking about, and we can go up to the directors and say like, hey, we think that this might be the way out.
We kind of have done it, right, for other things like ref structs, right, where we said, yeah, that's just the way things are, right?
Right. But with ref structs though, we've been ref structs into this point, we've been at least able to, kind of one of our mantras was like, okay, every time you have a span overload, have like a byte array overload. Like there's a way for this to work. And we might have to find, we would potentially have to invent something else for similar to that, for like caller identity or something like that.
Right, but we basically said at minimum we need to add knowledge to the compiler to bail if they don't understand things, right? So that's the tax we pay basically, right? If we add something to F# that C# doesn't support the other way around, we always add the code on the other end to say, yeah, but if you see this, you don't know what it is, you fail in a meaningful way. You don't just do stupid stuff, right? And I think that's kind of the same here, right? We would say, yeah, in order for us to support this, we have to remove these members. Therefore, F# needs to support this attribute so that code keeps compiling, right? Which seems reasonable. I mean, that's not horrible, I guess.
Well, maybe then kind of seems like maybe the conclusion is we find a couple interested parties on the kind of runtime team side, and we sit down and kind of map out where we think this would or would not be useful, and like what the other options would be for things like caller identity attribute. Cool. I don't know how you guys mark issues that way, but that's how I think it should be marked.
It's basically, I guess, needs work.
Needs work. Sounds great.
And then we can decide where we want to take this. But I mean, I like the way you think, because I think it is the trying to make it additive only. would be difficult for us, right?
Yeah, it's we're just getting but having to like be like, oh wow, we can do these like really cool features. Oh crap, that API we added 20 years ago. Damn it, it's in the way. Like it's getting harder and harder.
Well, while Emo's typing that up, I'm really glad you brought this up, Jared. Like I don't necessarily trust my own opinion on what the shape of this should look like, but I find the proposal honestly really attractive.
Awesome, great. I'm glad to hear that. So yeah, I think I feel like there might be something to do here. So I'm glad that you all like think that too. And so I'm happy, like I said, I'm happy to sit down and kind of like keep hacking on the ideas with someone and feel like where we can take it to.
You've taken a 10-pound golden carrot and dangled in front of particular API review members.
I actually 10-pound like that. That's kind of heavy. I'm not sure how long I can dangle that.
Yeah, I think that's a fair thing. All right, then I think this is it for today. We're already 12:15.
And we got through a huge number of the amount of the backlog today, which is great.
I think we did 9 or 10, right? Something like that.
Like 30%.
Yeah, something tells me by Tuesday we have 10 more because it seems to be the current way things go. All right, then thanks everybody. Enjoy your weekend, and then I see you next Tuesday.
Guys, have a good one.